not recording. Okay, so we picked up this paper today. We're going to take some notes on this. Then I'm going to return your papers from last class, and you'll use both sets of notes to help you work on the practice problems on those two sheets. And then I put it in the assignment last time that there was a brain genie, vectors part 1, but I don't remember telling you to do it. So I just changed the deadline for vectors part 1, and then there's a vectors part 2, and have both of those due next week on the 8th. So once you're finished with the practice problems while you're here to get help, then you can start working on the brain genies, and they'll be due next time. So a vector is a quantity that has both magnitude, which is length, and direction. It's convenient to use an arrow to represent the vector. The length of the arrow represents the magnitude, while the arrowhead indicates the direction of the vector. Compass direction, or navigational bearing, which is what we called it last time. I don't know why that happened. Is measured in degrees clockwise from due north. So the example that's given here, this vector has a magnitude of, so what's labeled as the length or the magnitude? For this vector here. For this vector, what's the magnitude? 5. And what's its direction? Give me degrees, but from north.
Oh, from north?
Mm-hmm.
Northwest?
No, I want the answer in degrees, but it's from north. So how many degrees between north and east?
45. 60.
90. Plus the 20 that you're given is 110, right? I don't know why this zoomed out. The compass direction or navigational bearing, north is 0 degrees, and it's measured clockwise. So from north to east is 90, plus the 20 gives me a total angle of 110. And then the length here is the magnitude, and it's labeled as 5. Two vectors are equal if they have the same magnitude and the same direction. Their position does not matter. So vectors v and u are equal. In this example, vectors v and u are equal, even though they are in different positions, because they have the same angle and the same magnitude. So any questions about that? From here to here is the same length as from here to here, and the angle is the same. In other words, they look parallel, right?
Are those cheese bites?
All right, so we're going to go to the next slide.
Where'd you get?
Operations with vectors. We can add, subtract, and do scalar multiplication of vectors geometrically or algebraically. The geometric method is called tip to tail. Simply place the tail of each successive vector to the tip of the previous vector. The resultant vector is drawn from the first tail to the last tip. All right, we talked about this initial and terminal points and tip and tail last time. That's on your All About Vectors sheet that you should still have. So this is vector u, and so this one is u, this one is u, this one is v. So my all right, the grids didn't print. Oh, we don't do it there. Okay. But we have to count them, though, right? So we have to count this and this, and it didn't print, so okay, I'm going to just make up a grid that says this is 2 across and 3 down, although that's not going to match this other grid, is it? Well, we'll just improvise. And this one looks like it's about 3 across and 1. We're going to call this one, no, if this 3, that can't be 3. So this will have to be 4 and 2. Okay, we're going to go with those sizes because the grid didn't print on your paper. So what I need to do, I want twice u. Okay, so I'm going to pick a point. I can pick that point anywhere. I'm going to go down 4. 1, 2, 3, 4, and over 2. And then I'm going to do that again. 1, 2, 3, 4, and over 2. So my resultant vector is here. So this is 2. Okay, you ladies need to be getting this on your paper. Okay. So twice u is to just draw u twice. So I went down 4 and over 2 twice. So that's 2u. All right, vector addition of u plus v. The order matters here. 2 plus 3 and 3 plus 2 are the same, but u plus v and v plus u are not the same. So we need to draw u first. So we're going to pick this. We're going to go down 4 and over 2. So this is u. And then v is over 3 and up 1. So that one is v. Oh, my v and my u look the same. So the resultant vector, I'm going to pick a different color. So the resultant vector is from the tip. The resultant vector is tip to tail. It's from the first tail to the last tip. So the blue one here, I just did that again and I don't know what caused it. The blue one is u plus v. That's what the blue one is. I'm counting them off based on the one we were given in the drawing up here. I just had to make up some numbers because you can't, the grid didn't print. Mm-hmm. Yes, just put how many they got correct. And, oh no, their points are, no, never mind. The points are in the top right corner. See where, on the paper you have in your hand? See in the top right corner? Okay, so any questions about this one?
Can you go over it one more time, Ms. Turner?
Okay, so I made up a grid because you can't see one and decided that this one was 4 down and 2 across. If I want to double that, I'm going to go 4 down, 2 across. That's one U. 4 down and 2 across again. That's the second U. So this vector is, this vector here is the resultant vector 2U. Then for U plus V, I have to draw U first, then V, then from the tip of the first one from the tip of the first one, I draw the second one. So I start right here where it ends, and I draw the next one. So I simply draw U, and then I draw V, and then, ladies, then we connect the initial point to the terminal point, and that blue one is your resultant vector. So that represents the sum of U plus V. So here, turn off. To move it up. Okay, for subtraction, you draw in the opposite direction. So I'm going to draw U. Oh, I don't need that. I'm going to draw U. 1, 2, 3, down 4 and over 2. So that's U. And then minus V, instead of going right 3 and up 1, I'm going to go left 3 and down 1. So that the positive one was over here, the negative one is just along a straight line in the opposite direction. So this is minus V. And then my resultant vector is here. Notice that the place I started with to the place I ended with is my resultant vector. So this blue one is U minus V. So I drew U exactly as it was, and I drew V in the opposite direction for minus V. So I want you to do this part. Draw V and then subtract U. So you should pick any point, go right 3, these grid lines are, and up 1. So that is V. And then I want to, from the tip of that one, I want to start U. I'm going to go, I do not know what I am doing. All right, so did everybody get this one? You need to keep up and make sure you're getting all these notes. Right. So we're going to the next slide. So now we're going to combine operations. And this grid really didn't print very well. So, all right, the grids didn't print very well, so we're just going to have to wing it on that. We want U, which is, whoops, switch to the blue. We want, yeah, there's no grid, so we're just going to wing it. 1, 2, 3, 4, and over 2. So that's U. Yes, sir. Okay. When you get back, you'll need to get the notes from everybody and get caught up. Now it's twice V. So we're going to go over 1, 2, 3, and up 1. Then we're going to do that again. 1, 2, 3, and up 1. So this is twice V. So my resultant vector is from here to there. So that is U plus twice V. Okay, questions? What's your question?
So they give us a rule, right? And then we just use that rule every single.
For each problem that goes with that one, yeah. Yeah.
Good job. How about
Subtraction is just opposite direction.
easy? Give me a test right now.
This was multiply. So I multiplied V by 2 by drawing it twice. So I drew it here, here, and here. That's twice. Okay, so now for the next one, we want twice U. So I'm going to pick a point. 1, 2, 3, 4 over 2. So that's 1U. Then I'm going to do that again. Thank you. Thank you, thank you. And over 2. So this is twice U. Now I'm going to subtract half of V. So we would go, instead of left 3 and up 1, we'll go left 1.5 and up 1/2. So we're going to go left 1.5 and up 1/2. Oh, no, we're going to go down because it was going up before. So we're going to go left 1.5 and down 1/2. So that is minus half V. Go down 1/2. So then my resultant vector. So the blue one here is 2U minus 1/2 V. So any questions about those?
How do you know it's going up?
You always, after you've drawn the two parts, you always draw from, oh no, I didn't, it isn't going up, thank you. That's a +1.
Oh, yeah.
Oh, I don't want to change that. This arrow's in the wrong place. The arrow should be going from the initial point to the terminal point. So the arrow should have been going this direction. Because you always go from where you initially started to where you ended. From your initial point of the first vector to your terminal point of the second vector. So that was Alexis. I need to remember to write that down. Okay. So. All right. So magnitude, and the formula is here again. All right.
You're high, right?
That's probably I make sense.
Okay. There seems to be a smaller grid. This looks like 5, 10, 15. I mean, I'm looking on the printed one, I can see larger squares with smaller squares inside. I can't see that on the screen. So then it would be from here. It's really hard to see those lines. It looks like there's one here, one here.
Is that a tissue of a pop?
Okay. So I'm looking at this as 3 by 4. I'm looking at this as a 3 by 4. So if we're going to find the magnitude, the sides, if we're assuming this is at the origin, which is fine to do that, then x squared plus y squared, x is 4 squared plus 4. So 4 on the x's and 3 on the y's. So my magnitude is equal to that, which is the square root of 16 plus 9, which is the square root of 25, which is 5. So my magnitude is 5. Now we can do this in vector notation. We can do it algebraically rather than drawing them with the graphs. Right. Does everybody have this part? Anybody not have this part? Okay. So. So, vector AB, remember we can name the sides and use the letters, or we can use the points. So vector AB plus BC, I hate it when it does that. So AB is 9, BC, so AB plus BC is going to result in this vector across the diagonal to get the resultant vector, and then we either want the resultant vector or we want the magnitude. So we need to find the distance from B to C, but it's a parallelogram, right? So BC has to be 6 because AD is 6. So the resultant vector is it's not a right triangle. Okay, let's do the magnitude, and I will refresh my memory on the formula for that. So this one is magnitude. So this one is just 9. This one is, I don't want that vertical one. This one is the square root of 9 squared plus 6 squared. That does not seem right.
Where do you get these numbers from?
The drawing right here on the side. So this is the square root of 49 plus 36, which is 84. So the square root of 84. Yes? What? Oh, I was doing, that's not a 7. You're not, you're right, that's a 9. All right, who was that? Who, what, who? Faith. So 9, 10, 11. So that's 117. Feels like I'm not doing this right. It's been too.
I made it. I mean, I don't care. I'm not gonna eat it. Just throw it away. It's like cheesecake. It's like layered cheesecake. Okay, I did say no.
Yeah, it was fun.
I mean, yeah, but then, like, after you're done, you're like, kind of breathe the air. You're breathing water. The only thing I don't like is just dribbling the ball. I don't know why you need to do the ball. You should dribble the ball.
Yeah, I was just annoying because
It's hard to with the ball because there's so many people where the water goes in.
Yes.
That's the only thing. Someone hit my ball. Yeah, before kicking it, my ball was flat. I'm like,
Someone hit my ball and it went over here. I had to go over here. Like, I'm over here. I had to turn around, like physically turn around to get my ball. It took 2 strokes. It got hit and another person hit. Bro, she just
the first time I did it all the way, and the second time, you know how you gotta like go to the middle and then back, and then go back. I was just flat. I was like, bro, you want to keep yourself down? I'm not doing it. No, you're sure?
I wanted to, but then I was like,
Sure. It was great. Everyone was like about to finish it. Everything was great. It's great.
Ah, no.
And then I heard them say that blue conditioning. I'm like, oh my god, I already know.
Digo que si se levanta va.
Other than that, it was easy.
we've had it worse in Sweden. Were you there whenever she made us carry her equipment back?
Bruh, I had to do buckets like once last year and once this year.
I wanted to be better. What is the right process?
I mean, you can do like cases now, like going fast.
About how much do you think you swim?
I was counting and I did counting to like 1,000, and after that I stopped counting. then when you look at it, like, I know, but I stopped counting after that. I was counting. Not with that. Next time.
Okay, when you're adding vectors, your answer is a vector. So A to B and from B to C is, in the right place, is A to C. So when you're adding vectors, your answer is a vector. Then this is not correct for number 7. Because I forgot what I was doing. This is not a right triangle. We can't just use the sides. We want the magnitude of A to C, which is the length of the resultant vector. So that's law of cosines. That squared is equal to the other two sides. So if this is 55, we know this is 125. Right? So we know that the two sides, we have side angle side. So that's 9 squared plus 6 squared minus 2. No. Is it 2? Law of cosines. Please open the door. Minus 2 times 9 times 6 times the cosine of 125 degrees.
What is the minus 2 coming from?
This is the law of cosines formula. A squared equals B squared plus C squared minus 2BC cosine of A from before. All right, so we're going to have to put this one on the calculator in degree mode. Right. Oh, you can't see it. So if we put this on the calculator in degree mode, we have 9 squared plus 6 squared. 9 squared plus 6 squared minus 9 times 6 times the cosine of 125. For that, we get 147.97, and then we have to take the square root. Yes? Oh. Yeah. You got your badge? Yeah, I'm not going to scan it today. Just take that. So, the magnitude of AC is approximately 12.16. Okay, so did everybody erase what I did before? So now we want the magnitude of AB plus the magnitude of BC. So for this one, we know the magnitude of AB is 9, and the magnitude of BC is 6. So this is equal to 15. That is a 6, right? Not an 8? Okay. All right, then AB, now this next one is interesting. AB is going this direction. CD is the same length going that direction. Remember that we said that two vectors are equal if they're the same length and the same direction. So these are the same length, but they're exactly opposite in direction. So this becomes the AB, which is 9, minus the CD because it's the other direction. So this is equal to 0. And it's the 0 vector. Because the answer to addition or subtraction of vectors is a vector. So this is the 0 vector. There's nothing left. Does any questions about that? It's the same length going in the opposite direction, so we subtracted it. So the answer to this one is the 0 vector. It's a vector of length 0. Sorry, didn't mean for that to happen. Why did that happen? Shoot, how do I go back? Oh well. The next one, this one is the magnitude of AB plus CD, which is the magnitude of the 0 vector, which is just 0.